Alright, hi everyone. So today's will be the third lesson for our topic 2, which is algorithmic and exponential functions. This is also the last lesson for this topic. Okay, so for today's learning outcome, we'll be focusing on two things. So the first one is to understand the definition and the properties of e to the power of x and log to the base of e of x. So, in short, we are learning what is that mean by natural logarithm. Okay. So the second thing that we are going to learn is how to use logarithm to transform a given relationship to linear form. Then you need to determine certain constant in the equation itself. So in short, we are learning how do we actually change something that plotted in curve and we want to change it into a straight line graph. Okay, so these are the two things that we are going to learn today. So I will be putting on like more focus for the second part because the first part is mainly like the definition and how do you use this natural logarithm in all the principles that you have learned previously. So they are actually the same thing. It's just that instead of doing like base 10, you are going to do like base e. Okay, so now let's start with the first one. What is that mean by natural logarithm? Okay, so what is that meant by natural logarithm? In previous lesson, we learned that y equals to a to the power of x. This is equivalent when we say that log to the base of a of y will be equals to x, right? So the base a here can be any number that you want. It's just that we might be more familiar with like log 10 because that's the common log that we use to solve exponential equation and so on. Okay, so in today's session, we are going to talk about another special base which is called as e. So what is e? E is an irrational number and the value of the number is like 2.718 and so on. So irrational number is like a number that in infinite decimal. So for example, you know that pi is equals to 3.142 and so on, right? So pi is an irrational number also. So you do not feel like E is like something that very difficult to understand. So you just remember that E is basically a number. So a number that is like infinite decimal and it's actually just a constant. Okay, so the function of y equals to e to the power of x is called as natural exponential function. So that's why if we say that y equals to e to the power of x, we can always write it in the form of log to the base of e of y equals to x. So this is called as the natural exponential function and this is called as natural logarithm. Okay, and sometimes instead of writing log, so it's like when we say that log 10, sometimes we will write it in the terms of like log or lg, right? So same thing for log to the base of e, we will write it in a way like ln. Okay, so they means the same. So when you look at the notation, you should know that it means log to the base of e. Okay, so now I want to try to introduce to you how's the natural exponential functions look like in a graph. Okay, so we'll try to see how exponential graph with e look like. So this is the normal graph. So it's basically like an exponential graph and the intercept will happen at 1. So if you have like e2x, then it's the same thing like what you have learned previously, like the stretching, the horizontal stretching, because you change your x to 2x. So the same thing if you have 0.5, then it will be stretching with a scale factor of 2. Then after that, this is the stretch factor of 1 over 2. Okay, so if you have something that is negative, right, it will be look like this. So reflection in the line of your y axis. Okay, so this is a positive graph, then this is a negative graph. So the same thing, so if we are comparing the e2x and the e negative 2x, so you'll get something like this also. So it's like a reflection lah, because you are changing your x to negative x. So how is that look like for your graph like this? So we know that if this is the graph of y equals to ex, right? So if log base e is the inverse function of e to the power of x, then they should actually reflect in the line of x equals to y. So I just put in a line. Yeah. Okay, so you can see that they are reflection to each other in the line of x equals to y. Okay. Okay, so this is like the key point from the graph just now. So we can see that the graph of e to the power of x and the graph of log to the base of e, they are actually a reflection to each other in the line of y equals to x. Okay, so they are inverse functions. So in short, basically log to the base of e undo the graph of ex. All right. Okay, so now I want to show you like some of the rules. So all of the rules for logarithm that we have learned so far can apply to all the natural logarithm as well. Okay, so what you need to do here is we will try to change all the log to the base a to the form of log to the base e. So this is like an idea for you when you want to solve the equation. So it's the same thing like when we say that if you want to solve an exponential equation, right? So for example, like 4 to the power of x equals to 7. So previously we know that we will always change it into log 4, then after that equals to log 7, right? So after today's lesson, you have one more alternative which you can do ln 4 to the power of x, then after that ln 7. So it's going to give you the exactly same answer, because the idea is that as long as you are using the log with the same base. Okay, so because here we are using like log to the power of log to the base of 10, log to the base of 10. So this one log to the base of e, log to the base of e. All right. Okay, so now let's try to go through all the rules together. So the first one is the one that we mentioned just now. So I'm just going to write it here. So if y equals to e to the power of x is equivalent when we say that, sorry, they write x first. So x equals to log, so we don't write log e lah, so ln, then y. Okay, so this is the same when we write log to the base of e of y. All right. Okay, so let's go to the next one. So log to the base a of a equals to 1. So we can always write, so yeah, to let you're more familiar with this, let's write loge first lah. So log e will give you 1 also. So it's the same thing if we only write that ln e equals to 1. Okay, so next one, log to the base of a of 1 equals to 0. So that's why log to the base of e 1 equals to 0. So it's the same thing. ln 1 will give us 0. Okay, so you can always try with your calculator and see whether you get it or not. Like ln 1. Sorry. ln 1 will give you like 0. Okay, so let's go to the next one. Log to the base of a to the power of x. So now log to the base of e to the power of x is equals to x also. Okay, so when we try to change it to ln, so it will be ln e to the power of x equals to x. All right, okay, next one. So same thing. So so e log to the base e of x equals to x. So we will have e ln x gives you x. All right, so you can like try it out. So if let's say I have things like let's try to check by using x equals to 2. So e, so shift, then you can see that's e, right? Then after that e ln maybe 2. So you should get 2 as well. So you see, all right. Okay, so next one, multiplication law. So the same thing. So we already know that log a, we can change it to log e. So let us just write ln. So ln xy equals to ln x plus ln y. Okay, so division law, x over y equals to ln x minus and y. Power law, so ln for x to the power of m, we can always write it in such a way that move your m in front of your log. Okay, so same thing to this. So ln for 1 over x, it can be changed to negative x. Okay, so same thing for equality rule. So yeah, as what I have said, we normally know that like you will change it to log x equals to, sorry, like lgx equals to lgy, because we are more familiar to like log 10, but actually any number you want to put as a can it is a correct statement also. It's just that your calculator cannot help you to solve that, so that's why we are using log to the power of log to the base of 10. So now since we have learned ln, so you can try to use log to the base of e as well. So x, sorry, okay, equals to y. It also means that x equals to y. Alright, so now we'll be looking at two examples together before move on to the second part. So I try not to put so many examples here because they are actually exactly the same like what we have learned previously, and I hope that you can try to you can try to learn and you can try to apply this into the exercise instead of like I giving you the answer itself. Okay, so let's try to look at these two examples. Okay, so the questions one here is just about the definition of natural logarithm. Okay, so e to the power of x equals to 45. So how are we going to solve this? So it's the same thing, we write it in the form of logarithm. So since we want to get x, right? So we can always write it in the form of log to the base of e 45 equals to x. So meaning what is x? X is natural logarithm of 45. Okay, so just by using your calculator and then ln 45, and it will gives you the answer. So 3.807. Okay, so after you get your answer, you can actually use your calculator to just check it again. So since now 3.806 is your answer, right? So you can straight away check it by using like Shift E. Then after that, put your answer as your power. Then you should check it and see whether it's correct or not. Okay, so that's for questions one. So let's move on to the next one. Okay, question two. So solve the logarithmic equation and give your answer in terms of e. So I will try to show you in two approach also. So depends on you like which one you want to take, but both is fine for me. Okay, so the first one is by using the definition of log to the base of e. So we know that the definition is like y equals to ex, then we can always write it in a way like log to the base of e, y equals to x, right? Okay, so ln 1 minus x equals to ln x plus 1. So what you can try to do is you try to group the term with natural logarithm together. So 1 minus x, that minus natural log of x equals to 1. So this is two term of log minus each other, right? So minus, we can always combine them into one term by doing division. So it's the same principle like what you have done using log. So equals to, how can we 1? Okay, so now how can we try to change this form back into the indices form or like exponential form? So the base is like the e, right? So e to the power of 1 equals to 1 minus x over x. Okay, so the same thing, I can continue to solve it. So ex will equals to 1 minus x. So now since I want to find x, so I try to group the x term together. Okay, so for me to get x, it will be equals to 1 over. So when you need to do your factorize, okay, maybe do the factorization. So x e plus 1 equals to 1. So you will get your answer as x equals to 1 over e plus 1. Okay, so this is one method. So the other method is by using the principle or the law of equality that we have learned. So we know that like log x equals to log y. We can always say that x equals to y. All right, so that's why log of 1 minus x equals to natural log of x plus 1. So let's try to change 1 into logarithm form. Okay, so what is equals to 1? It's like log to the base of e, correct? So we can always write it log e. So it's the same thing. So ln L by 1 minus x equals to ln x plus ln e. So how can you combine them? So this is multiplication, right? So ex. So I have both sides in log already. So that's why I can always say that 1 minus x equals to ex. So since I want to find x, the same thing I will do as the previous questions here, equals to, do I do anything wrong here? Oh yeah, plus, correct. So 1. All right, so x e plus 1 equals to 1. So what is x? 1 over e plus 1, which both of these approach give you the same answer. Okay, so these questions you can always use your calculator to check your answer as well. So just try to feed them into your original equation and then to check it. So your x is 1 over your e. So if you don't have anything, then you just put 1 lah. Okay, then after that plus 1. Alright, so you get the answer. Then this is the answer that fit in here, right? So 1 minus answer, then after that natural log your answer. So you see you get negative 0.313. So you can check it out again. So 1 over e1 plus 1, plus 1, then after that plus 1. Alright, so you can see you get the exactly same answer, so you know that your answer is correct. Alright, so yeah, I hope that you can try to understand the whole thing. So just keep in mind that you are actually doing the exactly same thing, but just that now you are doing different base. So you must make sure that when you try to change it, like if let's say you are doing log x equals to y, when you change it, then you should be having like log y equals to x. So if you are doing natural log of x equals to y, then when you change it into index form, it should be like e y equals to x. So this is like something that very important that you don't want to mix it up lah. So meaning if you are using like log to the base of 10, you please do not change it into e. So if you are doing natural log, when you try to change it to indices, you cannot do base 10 also. Okay, so that's the idea of it. So now let's try to look at the last part of this lesson. Okay, so let's try to look at the second part of the lesson, which is transforming a relationship to linear form. Okay, so since you all learn chemistry, biology, or physics, so we know that normally when we try to carry out an experiment, what we are trying to do is we want to find what is the relationship between two variables. So for example, in your experiment, then it will be your manipulated variable and your responding variable. And in mathematics, right, so if you have something that you can investigate in terms of like numerical data, then you will normally have a graph that you have your manipulated variable and your responding variable, right? So if let's say I get a set of data that can be plotted in something like this, So I can definitely see that what I can try to do is I can always fit a straight line in the model. So this is like a linear model which we will try to model it in the form of y equals to mx plus c, which we know that the m is the gradient of your straight line and your c is the y-intercept. But we know that in like normal in like usual days we don't really always get a set of data that can be fitted into a linear model which is a straight line. So what do we need to do when we get a data plots that lie on a curve? So in this case we can try to use log to help us to convert the curves into the straight line. However, it's not applies to, it's not that all the curve you can convert it into logarithm, but we are looking at two special cases here, which is the form of y equals to kx to the power of n, and a y equals to kx a to the power of x, which your k, a, and n is constant here. Okay, what's the difference between these two forms? The idea will be like, maybe I give you an example here. Let's say if I have something like y equals to 5x to the power of 3. So you can see that the variable here is the x here and the y here. So meaning the variable that you are having is the base of the indices here. So the second one, we are talking about something like y equals to 5, then after that 3 x. So the variable that you are dealing with is the power of this relationship. Okay, so we are looking at these two form of curve in this lesson. Okay, so for us to change it, to convert it into linear form, you can actually change it into any log with any base. But then, as what I said, normally we will try to change it into log 10 or the natural log, because those are the two applications that we can solve by using calculator. Okay, so how do we actually do that exactly? All right, so maybe let's try this out like two simple example so that you can try to see how are we going to convert a curve to a straight line equation. Okay, let's say if I have y equals to kx to the power of n. So what do we need to do is we try to put log to both sides. So since we learn natural log today, so let's try to use natural log. But of course, you can try to repeat the whole process again by using log to the base of 10. They will give you the exactly same thing. Okay, so let's say I will try to put in natural log, natural log. Okay, so now it's not in the form of y equals to mx plus c yet. So how should we rearrange the whole thing so we get y equals to mx plus c? So for this term, we can always try to expand it, right? So natural log of y equals to natural log of k plus natural log of x to the power of n. All right. Then after that, I will try to move the n to the front of natural log of x. So now I'll try to rearrange it. Okay, so we are in the form of y equals to mx plus c now. Okay, how do you actually see it? This part is your y. Your n is your gradient. Your natural log of x is your new variable x. So, okay, you see, why am I using a capital letter x and y here? Because I want to differentiate the difference of my original value of x and my new x, and the original value of y and my new y. So my new y is natural log of y. My new x is natural log of x. So this part will be my y-intercept. Okay, so don't worry, we'll be trying to look at this question again by using questions. Same thing if I have this term. Okay, I just want to make sure of this. So you do not need to memorize this. Everything you can just do it when you get the questions itself. So this is like an idea of it. I just want to show you how do we actually convert the curve into a straight line equation. So let's say same thing here. So I'll try to put natural log as well. Okay, so same thing, expand it. So I'll try to bring the x to the front of natural log of a. Okay, now rearrange it. So you can see where is the term that you have the x is over here. So that's why, because I want the m in front, so I will try to rearrange them like this. So this part is the new y, and this is my new gradient, and this is my new x, which is exactly the same value. I do not need to change the x part. And this is my y-intercept. So what is that actually mean is like, for example, when I have this, right, then maybe I'll get something like, when I try to plot it, then I'll have x and y. So when I try to plot the data here, I'll be able to get a curve. So I mean, I don't know how it's that look like, but maybe something like this. But when I try to draw it into a new graph, which a new variable, which is natural log of x and natural log of y, I will definitely get a straight line. I mean, the line here might not be the same, but I'm just telling you the idea is that we are converting a curve into a straight line by doing some changes into the variable. So for this case, because your x is not changed, right? So that's why when you're trying to change it into a straight line, then it will be x versus ln y. So that's the idea. Okay, so something to take note here is that when you try to change it, right? When you try to change it into a new form of y equals to mx plus c, the constant of m and c must contain your constants only. You cannot have any variable in your equation. So for example, like this equation, so y equals to kx to the power of n. So in this case, k and n is a constant. So that's why your k and n can only exist for your gradient and your y-intercept only. And then for the part where your variable, which is x and y, for these two variables, it can only exist for the part for your new x and your new y, which is a variable. So that's why when you look at this question, this is why I need to rearrange it, because ln A gives me a constant. So that's why it should be a constant in y equals to mx plus c as well, which is the gradient. And then when I write x, so this is the variable that keep on changing, right? So that's why it should be the part for x. Then ln k gives you a constant as well, so it should be the part of c. Okay, so it's actually not very hard, but let us just try to look at like few example, then you can understand it better. Okay, so let's try to look at example 3. Okay, question 3. So we need to convert this exponential equation into the form of y equals to mx plus c. So the same thing, when you try to look at this equation, right, you can see that there's an e inside. So comparing log to the base of 10 and the natural log, then of course natural log will be much more easier in these questions because you have an e here, which in the process itself, maybe you can try to simplify each other. Okay, so we'll try to take natural log to both sides. So try to expand it. Okay, then after that, when you look at this part, so you know that bx can be bring forward, right? Then after that, log to the base of e gives you 1. right? So that's why you are left with natural log with y equals to natural log of a plus bx. Okay, so this part is basically come from bx. So this part give you 1, so bx multiply 1 give you bx. Okay, so after you have reached this step, so is this in the form of y equals to mx plus c yet? No. So because when you can see here, maybe for the y, yes, because you have a variable at the term of y, right? But when you look at here, it's like a natural log of a. So this is a constant which doesn't fit into the part of mx. So your x should be a variable, which is your x here. So that's why we need to rearrange the equation in a form of bx plus natural log of a. Okay, so now bx, you see b is a constant which can be fit into the gradient part. Then your x is a variable which can be fit into the x part. So that's why comparing with y equals to mx plus c, okay, you can obviously see that y equals to natural log of y, then your x is still the same x that you have. Your gradient will be equals to b, and then your your y-intercept will be equals to natural log of a. Okay, so now maybe let's try to look at example 2, which we have a number for the constant part that you can understand it better. All right. Okay, so questions 4. The table shows experimental values of variable x and y. By plotting a suitable straight line graph, show that x and y are related by the equation of y equals to k times x to the power of n, where k and n are constant. Okay, so from this question, what you need to do is they are related with this equation, which definitely when you look at this equation, it cannot be a straight line graph, right? So that's why the first step that we need to do is we need to convert this curve into a straight line first. Okay, so so y equals to k multiply with x to the power of n. So let's try to do natural logarithm as well. Y equals to natural log of kx to the power of n. Okay, so now let's try to expand it. Rearrange, bring your n forward. Okay, so you can see that the variable part is still here, so that's why I should try to change the place of the term. Okay, so when you reach this step, you should can realize that this is in the form of y equals to mx plus c already. So what do you need to do is the straight line graph will look like y is natural log of y, x is natural log of x, and your gradient will be equals to n, and your your y-intercept will be equals to natural log of k. Okay, so now since we know that what is our new variable already, so based on this table, we need to create a new table with a value of natural log of x and natural log of y. Okay, so let's try to do that. Okay, so let's try to put them into a new table. So since we know that our new x and our new y, so this is the new x, then this is the new y. So the new x that you need to do is natural log of x, then the new y is natural log of y. Okay, so now from your original table, we need to change all the value into natural log. So just by using your calculator, so let's say the first one is natural log of 5, right? Okay, so you just put in your value here. So maybe let us just try to do like three significant figure here. So 1.61 Okay, so same thing for your uh, value for y. So natural log of 2593. Okay, they will give you 7.86. So you can try to use the same method, try to find out all the other value, which I will just write down my answer here. So 7 point. So please try to check it out by yourself. So yeah, do not try to copy. Yeah, so 6.89. Then after that 3.69, 6.41, 4.38, and the last one is 5.92. Okay, so now with this value, then you need to try to plot it in the graph. Okay. Okay, so let's try to draw it. So you can just draw it on the graph paper, then after that check your answer. So we have a new x variable here, which is natural log of x. Then after that, new y is natural log of y. Okay, so now we can try to plot the points that we have found just now. Okay, so you should be able to get a line that you can pass through all the points together in your graph. Okay, so now we'll be using this graph to answer our questions in part B. Okay, so B, use your graph to estimate the value of x and the value of n. So from just now, what we have just now, right, we already know that our gradient will be equals to n. So meaning in another words, how to find n? N is basically the gradient of the graph that you have drawn just now. Okay, so meaning that when we want to find n, it's finding the gradient from the graph. So from the graph, we know that just now we got a straight line, right? So all the lines actually pass through all the points that we have plotted just now. So you can just take whatever any 2 points, because when you look at this question, it's like estimate. So actually you cannot get a very exact answer which give you like very accurate answer, but what we try to do here is estimate. So you can get any point that given here, then after that you try to use the formula of y2 minus y1 over x2 over x2 minus x1. Okay, so let's say maybe in this question, let's try to pick 2 points here. So maybe let's use the last one here and the first one maybe. Okay, so we have the point of n equals to, so the last point here give us 5.92, and then after that minus the first point 7.86, divide by 4.38 minus 1.61. Okay, so basically I'm using like this one is my x1 y1 and this one is my x2 y2 lah. Okay, so for me to get the gradient, meaning that I'm just using my calculator to solve this, then I can get the answer of 5.92 minus 7.62 divided by 4.38 minus 1.61. Okay, so give me three significant figure here, 0.700. So this is my estimation for the value of n here. Okay, so now let's continue with the value of k. So we know that the intercept, the y-intercept will equals to natural log of k. So since we want to find k, meaning that we need to know the y-intercept. So let's check the graph that we have drawn just now. So what is the y-intercept here? It's like roughly at 9. So that's why we can substitute c as 9. Okay, so 9 equals to natural log of k. So how can we solve k? So we know that natural log is log to the base e, right? So that's why e power 9 equals to k. So you can just use your calculator to get your answer, which is 8103, like roughly. Okay, so I hope that this question give you an idea of like how actually the converting works in like a relationship from a curve to a straight line. Okay, so let's try to look at the very last questions. Okay, number 5, the variables x and y satisfy the given equation. A and b are the constant. So the graph of natural log of y against x squared is a straight line passed through the points given here. So you need to find the value of a and b correct to two decimal place. So this question, they give us the equation y equals to Okay, number 5, the variables x and y satisfy the given equation. A and b are the constant here. So a graph can be plotted with a straight line passing through the 2 points given. So what you need to do is to find the value of x and y correct to two decimal places. Okay, so in this question, they give us the equation here, which is y equals to a multiplied with e to the power of negative bx squared. So, and they said that you can draw a graph that is natural log of y against x squared with these 2 points. So 0.55, 0.84 maybe somewhere here. So 1.72 is to the right, but then it's like lower. So it might be something that look like this. Okay, so by looking at this equation, you can definitely see that this is not a straight line equation. So that's why when you can plot this graph, meaning that they try to convert this into a linear form. So what do we need to do here is we need to change it into the form of y equals to mx plus c. So same thing, take natural log to both sides. Then after that, what we can try to do, expand it. A natural log e negative bx squared. So we know that natural log e will give you 1, right? So that's why you will have an answer for negative bx squared over here. So is this in the form of y equals to mx plus c? No, because this form is a constant. So natural log of a is a constant, right? So that's why we need to rearrange the whole thing again. So equals to, let's try to move this in front. Okay, so you can see that this one is basically your new y. Then your gradient will represent by negative b. And your new x is x squared. Then after that, your y-intercept is your natural log of a. So when you try to compare it, then you will get your new y is natural log of y, new x is x squared, and your gradient is negative b, and your y-intercept is natural log of a. So when you try to compare with this graph, you can realize that it's correct because your new y is natural log of y, right? And your new x is x squared. So which is satisfied into the graph that given in this question. So now by using the information that we have, then we need to find out the answer. Okay, so how can we do that? So since it's given 2 points already, then obviously we can get what is the gradient, correct? So that's why b negative b equals to gradient. So your b will equals to negative gradient. So you can find out your gradient here, which is same thing. You can try to do x1, y1, then x2, y2. So let's try to do 0.26 minus 0.84, then divide by 1.72 minus 0.55. And you should be able to get the answer of 0. So to two decimal places. So that's why 0.50. Okay, so you can try to use your calculator to get that. So now as you have gotten your B, then how you can find out your C? So this equation you are not given the data to ask you to draw a graph, right? So meaning what do we need to do here is to try to fit in the value that we have, then to find out what is C. So we can always use y equals to mx plus c. So please bear in mind that it's the capital letter of x and y because it's the new equation that we transform from original equation. So to substitute here, then we can use any number that you want. So meaning two of this point, any point will give you the exact same answer. So 0.84 equals to the gradient that you have found just now. But please make sure that this is B. Your gradient here should have no negative. So that's why the answer that you are having, it should be a negative something. So negative 0 point, then you can write down the answer without rounding first. Okay, then after that, your x is 0.55, then your C. So you can try to use your calculator as well. So it will be better that if you still have your value in your calculator, right? So let's use the original value so you can get a much more accurate answer. So multiply by 0.55, then after that 0.84 minus your answer. So you should be able to get 1.1126. All right. Okay. So now you can try to find out already. So since you have your C already, right? And just now we say that natural log of A equals to C. So meaning we can always solve it by using A equals to e to the power of 1.1126, which gives you the answer of 3.04 in two decimal places. Okay, so this is how you get your answer. So basically your last one, so just write down. So your B is 0.50 and after that A is 3.04 in 2dp. Okay, so that's it for today's the last part. So I'll try to do a very quick recap as the end of this lesson. Okay, so I'm just going to do a very quick one because this topic is quite short and you just learn it within this way. So I think that all your memory is still there. So that's why I'm not going to repeat the whole thing again, or else it will be a very long video. So at the end of this, just want to like do a very quick wrap up. So so far in this lesson, you know what is the definition of logarithm. So the idea is just like what is that meaning by if you have y equals to a to the power of x, you can always write it in the form of log a y equals to x. Okay, then after that you learn make sure that you still remember what are some of the principle or the laws that you have in the logarithm, like the multiplication law, the division law, the power law, and so on. Okay, then for the after that, after you learn this, right, then you use this to solve some of the log equation. Then you also learn how to use this to solve your exponential equation. Then also the last part, which is your exponential inequality. Then for today's lesson, it's pretty much on the part of like you have the definition of natural logarithm. Okay, which is y equals to e to the power of x, then you can always write it in ln. All right, so this is log to the base of e, and then y equals to x. Then same thing, you can use this definition to help you to solve equation, exponential equation, or even like inequality. So it's the same part like the first one. Then after that, the last one is you learn how do you transform or how do you actually convert a relationship to linear form, which is the part that we learn in the last part for this lesson. Okay, so that's the close up for this chapter. So please make sure that you go through all the past year question and the review that you have in the exercise. Okay, so that's it for today's lesson. Thank you.